Alright, so we are back talking about quantitative reasoning portfolio assignments. So we've talked about 3 so far, and the 4th one is actually the final one that's due here in a little while. Well, depending on when you're watching this video, when it's due soon, okay? Or maybe it's a little far off if you're ahead of the game. So, this is actually the 8th out of 8 portfolios assignments. And if you want to figure out which one that is, go over here to course content, go to portfolio assignments, and it's this one right here. Page 303, lesson 4.7, technology 1. So let's actually pull that up in our ebook and see what we need to do. Okay, so this is page 303. Technology 1 is what we're doing today. So it says create an Excel spreadsheet to explore whether or not the answer to question 8C in the class portion of this lesson is correct. Make sure to input a wide variety of x values, positive, negative, fractions, decimals, even irrational numbers if you want to impress your teacher. Can you be sure that the two expressions are equivalent by inputting a variety of values? Explain. Bonus points for doing some online research about when two polynomials are equivalent. There's a template to help you get started in the online resources for this section. So we need to make something that looks like this, and we want to input a variety of values in column A, or list a variety of values in column A, and use those values as inputs to this expression and to whatever expression is going to go there. Okay, so let's first, before we get too far ahead of ourselves, let's go to the additional course resources to get our template. Now it says lesson 4.7, so course content, additional course resources, unit 4, and lesson 4.7. And there is our template. Okay, so open up Excel. Of course, you need to hit Enable Editing. Now, admittedly, this is not much of a template. It wouldn't have taken long at all to type this out, but it saves us a minute or two. Now, what does it say here? Type your answer to question 8C from the class portion of this lesson in cell C1. So there's cell C1. We're going to put the answer to 8C there. You'll need to use the caret symbol when you want to indicate an exponent. Then enter a variety of values in column A and use formulas to calculate the value of the expression in column B and C. Okay, let's see here. Here's something we haven't gone over. Maybe or maybe not, since we've been doing these videos. If you ever are working in Excel and like you're typing too much, a lot of text into a cell, and all of a sudden you can't see all the text, like there we're supposed to say input and then X in parentheses, but we can't see all of that text. You can always click here on the line between the column headers, and we can make those bigger if you want to. Make those bigger. And we're probably going to need some more room here, maybe, depending on what answer to 8C is. Now, I guess we need to look at 8C first, because that's a pretty big part of this portfolio assignment. So let's go back to the ebook and see what the answer to 8C is. Okay, so we need to scroll back up here. 8. Okay, here's 8. The goal is to multiply these two polynomials, x minus 5 and x squared plus 3x plus 4. Okay, we're going to multiply those two things together. Okay, so let me write this down, and we're going to have to talk about how to get that solution there. Because depending on when you're watching this video, you may or may not have covered this in class yet. So x minus 5 times x squared plus 3x plus 4. Okay, let's figure out how to do that. if you haven't done that already. So questions 8a and 8b kind of lead us into the final solution of 8c. Now let me pull up another program here and we'll talk about this. Okay. Alright, so we want to, let's see here, multiply. We said, let's see, we have x minus 5, and we have, ooh, my handwriting always takes a few minutes to get used to this pad here. So x minus 5 times x squared plus 3x plus 4. There we go. The first few structures are always a little bit to get used to. Okay, alright, so we want to multiply that. Okay, now let's go with a easier example first off to the side. And I know you've seen this at some point. Let's say we have x minus 5 times, let's say x plus 4. Now, usually when we do this in class, most everybody remembers how to do this. They remember it's called, the method we use to multiply that is called the FOIL method. Okay, which stands for first, outer, inner, and last. So you multiply the two first terms in each of those polynomials. Now specifically those are binomials because they only have 2 terms each. So you multiply the first 2 terms, then you multiply the outer 2 terms. Here, I'll go ahead and I'll draw some curves here. Multiply these 2, and then you multiply the outer terms, then you multiply the inner terms, and the last terms. So you multiply x times x, then you multiply x times 4, then you multiply negative 5 times x, then you multiply negative 5 times 4. And then you add all those things together. So the solution here, so what's x times x? Well, x times x is x squared. So let's say here, it's x squared. X times 4 is 4x. Negative 5 times x is minus 5x. And then negative 5 times 4 is negative 20. Okay? The only last step to do is to combine any like terms. And you notice the only like terms we have here are 2 x terms. So we have just one x squared term. We have a plus 4x and a negative 5x. If you combine those together, how many x's do you have in all? That's negative 1x. And then we have minus 20. Okay, so that was how we multiplied when we had 2 binomials. You see there's 2 terms in that polynomial and 2 terms in that polynomial. Now, if we go back over here to what we need to solve for our portfolio, you notice we have a binomial here, x minus 5, but we have a trinomial over here, a polynomial with 3 terms. Okay, so we're going to use an extension of the FOIL method. So it has to, there's going to be a few more steps here, but it's the same basic idea. So let's see here. If we go back here, we're going to multiply these 2 terms. Then we're going to multiply these 2 terms. And then we're going to multiply these 2 terms. And then these 2 terms. Then these 2 terms. And these 2 terms. then we're going to add all of those up. Okay, so let's see what we get here. So the first two things we multiply are x and x squared. Now, be careful here. X times x squared, that is x cubed. Okay? Now we're going to multiply x and 3x. Okay, x times 3x, that is positive 3x squared. Next we have x times 4, which is just pretty easy. That's 4x. Now we're going to multiply negative 5 by each of these three terms on the right. So negative 5 times x squared is negative 5x squared. Negative 5 times 3x, that is negative 15x. And lastly, we have negative 5 times 4, which is negative 20. Now, we need to, just like we did over here, combine like terms. So look through all of these terms. Looks like we have 6 terms there, and figure out which ones have the same power of x. Okay, well, I only see one x cubed term. So there's no like terms to combine for cubes. Okay, but what about x squared terms? X squared terms, I have one right there, and I have one right there. So I have 3x squared, and I have negative 5x squared. How many do you have altogether? That's going to be negative 2x squareds. Okay? Then I have an x term right there, and an x term right there. So I have 4 x's, and I have negative 15 x's. So when you combine positive 4 and negative 15, you have negative 11 x's. And then I have a minus 20, and there's no other constant term. I only have one constant term, so nothing to combine there. And so there is the product of x minus 5 and x squared plus 3x plus 4. That is the answer to 8C. Okay? That was what we needed in the like the column C of our spreadsheet. So we can go back to Excel now and start working and see what it's asking us to do. So x cubed minus 2x squared minus 11x minus 20. Okay? So I'm going to write that down, and then we're going to go back to Excel and type that in. So let's see here. X cubed minus 2x squared minus 11x minus 20. Okay, back to Excel. So go over here. So now we need to type the answer to 8C right here. And I'm going to unplug the tablet so it doesn't make my cursor all crazy. Okay, so answer to 8C. So we said x cubed. Now, notice here it says you'll need to use the caret when you want to indicate an exponent. Like right, there we go, just lost my cursor. That right there, x caret 2, that says x squared. And that's how you usually have to type exponents. Anytime you're typing them, you know, of course, if you're like in Microsoft Word, you can click the superscript button and it looks nicer. But if you're like typing in Google or Excel, that kind of stuff, you use the caret to indicate exponents. So we have x caret 3, that's saying x cubed. Then we have minus 2x raised to the second power. Here, I'll move that. Then we have minus 11x minus 20. That's the answer to 8C, right there. Okay? Now, what do we need to do? Let's see here. Then enter a variety of values in column A and then use the formulas to calculate the value of the expressions in column B and C. So what we're saying to do here is enter a variety of values here. Now, the text on page 303 said to enter big numbers, small numbers, negative numbers, fractions, decimals, a variety of numbers. So let's just type in a bunch of random numbers, maybe 10 or so. 0 is always good. What about 0? What about some decimal? So let's see. Oh, we can just do an approximation of pi, I suppose. 3.14. Okay, there's a decimal. What about a negative number? Negative 238. Okay. What about a positive big number? What about, so just whatever I type. There's a positive big number. What about a negative fraction? So negative, what about a really small fraction? So 0.00154. What about an irrational number? Now, here's a little trick for you. Let's see if I remember how to do it. If you want to type in like a square root of 3 or 2, those are a lot of times end up being irrational numbers if it's the square root of not a perfect square. So let's see what we have. Let's type in the square root of 2. SQRT, I believe, will give us a square root, and then put your whatever number you want in parentheses. Oh, nope, I need to put an equal sign there, so we'll calculate the square root of 2. Yes, there's a square root of 2, 1.41 and change. Oh, let's put a few more. I said 10, so we start at row 2, so we need to go to row 11. Now, I think if I put a fraction there, Excel is going to want to change it to a date. But maybe if I put a fraction that can't, let me see here, 13 over 349. Yeah, okay. If you put a fraction in that might be like, could be interpreted as a date, like if I put 1 comma 15, see what happens? Excel sometimes tries to do a little bit too much interpretation, which is, usually when we type a number like that, it is going to be a date, but right now we don't want a date. So I had to type a combination of numbers that I couldn't mistake for a date, since that's obviously not a month, year combination kind of thing, or sorry, excuse me, a day and month combination. Okay, let's see here. What about just a couple more random numbers? And what about a really big negative number? So 51,874. All right. So there's one more, and I'll do one more regular counting number. Let's just say 5. Okay. There we are. So we have some plain Jane numbers. Then we have some crazy decimals, fractions. We wanted to input a variety of numbers, is what the directions asked us to do. Okay? Now, it says to use these numbers to evaluate these two expressions at these inputs. Now, we need to take these numbers. Let's talk about the first, this 0 right here. We want to take 0 and substitute it in to this expression everywhere there's an x. Okay? If we were talking about function notation, which we don't in this course, and we were talking about this function right here, we would say f of 0. But we're not really concerned with that since we don't really touch on function notation in this particular course. But we're going to evaluate this expression at 0. So instead of seeing x's, we want to have zeros, but we don't want to type zeros. We want to type the cell reference that 0 lives in. And what cell does 0 live in? Looks like A, column A, and row 2. So that's cell A2. So we want to type a formula that plugs in, substitutes in 0 everywhere for x in that expression in column B. So remember what you always do when you start with a formula, equal sign. That's all you have to do with a formula. That tells Excel to calculate. So we need to type it more or less exactly what is in above, but we have to do a few modifications. But we still need those parentheses. So we want to say, instead of x, everywhere there's an x, we're going to type A2. So A2, notice it highlighted cell A2 in blue, and then the text A2 is in blue, so that shows we're doing the right thing. Minus 5, close parentheses. Now, when we're just writing answers out, we can indicate multiplication by placing two adjacent sets of parentheses, by placing two sets of parentheses adjacent to each other. And we just understand when we write on the paper that means multiplication. But we need to follow the conventions of Excel, which Excel says when you multiply things together, you need to use the asterisk symbol. So we need to use the asterisk symbol there to indicate multiplication. Then open another parenthesis, and it's x squared. But again, we're not typing x, we're typing cell A2. Then we're going to use the caret symbol to indicate squared. Then we're going to say plus 3 times x, but again, x is, we're just letting be A2. Oh, times, I forgot my asterisk, times A2, then plus 4, then close the parentheses. Now when I hit enter, since we put an equal sign in front of all this, Excel is going to take whatever input I have in cell A2 and evaluate the expression at that number. And so if we type this all correctly, this means that when you plug in, when you substitute in a 0 into that expression, the result is negative 20. Okay? Now, that's a little tedious, admittedly. It's not as bad as it could be, but it's not necessarily fun. You need to do that same type of thing for all those cells right there. Now, that would take a handful of minutes, but we're going to take a shortcut because there's no reason to waste time if you don't have to. Assuming we typed this in correctly, let's double check ourselves. A2 minus 5 times A2 squared plus 3 times A2 plus 4. So it looks like we're correct. We can copy this formula and paste it for that entire column B. Oh, what happened over there? See what happened over there? I didn't notice that we had a date conversion. We had just talked about that. Let's get a negative fraction. Let's say negative 15. Oh, let's get an improper fraction. It might just give me a decimal. I don't know. We'll see. Let's say negative 781 divided by, let's say 152. Wonder why that is. Oh well. It doesn't like that. At least it says it's there, but maybe it's trying to display more digits. I'm not sure. Since I'm not sure what's going on there, we will just make this a little different. What about that? Oh, I wonder if it's... There we go. It was formatted to be a date. So up here, this is actually a really useful tip. It thought I put a date in there, so it was formatting all those as dates. And I went up here and just said general. I could have clicked number as well, and that fixed it for me. Okay, so that's all good there. Now what do I want to do? I want to continue typing this formula into all of those rows. Okay, but again, I can just copy this, and Excel knows that if I paste right here, it's going to take whatever cell is directly to the left and use that as my input. So see there? We didn't have to type A3, and we typed A2 right there. But Excel knew to take whatever's to the left, in this case A3, and substitute it into my formula. Okay? You can either copy and paste individually, or you can use the little trick I showed you. Again, just to review, if you want to paste in a bunch of open cells, what you can do is select all those cells at one time. So click on one end of your cells, hold the Shift key, and click on the other end of the cells you want to paste in. Then you can either hit Control V to paste, or you can right-click and paste. I'm just going to hit Control V. And there we go. Why is it saying value there? I wonder if it's, let's turn that to a number. Now this to a number. Oh, it doesn't like that. I wonder why that is. Probably has some sort of formatting issue here, since everything else worked out nicely. So let's change this. I wonder if we put an equal sign there. Yeah. Okay, we needed to tell Excel to actually calculate that fraction. So for some reason, so be careful if you're using fractions like I just did. Put an equal sign there so it actually calculates the fraction. And it looks like we're good there. Okay. So if you get any of those weird value error messages, it's probably because we used a fraction on this input column and Excel wasn't treating that as a number. Okay, so we got all numbers there, so let's review what this says. This here says if we take 5 and substitute 5 everywhere for x in that expression, 0 is the result. Similarly, if you take 0.04, substitute it into this expression, the result is negative 20.41. And now you see this, we have probably talked about at this point, or if not, we'll talk about it soon, scientific notation. That's a version, well, not exactly scientific notation, but it's maybe not what we see in the book, but it's a version of scientific notation there. So let's see here. Now let's go into the next column. So we want to do the exact same thing, except this time we want to take our inputs in this column and plug them in, substitute them in to this expression. And watch what's going to happen. We'll see in a few minutes. There's something cool is going to happen. Okay, so let's just take A2 again. And let's take A2 and substitute it into that expression. So we need to type equals, because we're typing a formula here, always equals. Okay, now we have x cubed, but we don't want to type x, or we don't want to type 0. We want to type the cell A2. So A2, we want to raise that to the third power, so caret 3. Then we want to subtract 2. Now, it's not just 2 times, it's not 2 then A2 right after, it's 2 times cell A2. And A2 is squared in that term. Then minus 11 times A2, but remember you have to use an asterisk for times in Excel. A2 minus 20. Now let's see what happens whenever we hit enter. Now what do you notice here? A negative 20 and a negative 20. So what this tells us is that when we substitute in 0 into this expression, the result was negative 20. When we substitute 0 into this expression, the result is negative 20. That's interesting. So we'll draw a conclusion in just a second. Okay. Now let's continue this pattern with our formula. Again, we can either type this formula another 9 times, making references to the respective value cell in the A column, or we can just copy and paste our formula. Again, that saves us a bunch of time, plus it's easy to make a mistake when you're typing this kind of complicated formula there. So let's copy, and then we can paste. You can always just use this first paste option there. So paste, paste. The other options just deal with formatting, like if there was different formatting issues and stuff like that. So we'll just do that, and then we can select the rest of those empty cells all together and paste all at one time. Now here we notice that all of these, oops, I didn't mean to do that. Let's delete that. Okay. All of these cells in column C and column B, B and C, you notice they are exactly the same. So again, let's just review. That tells us that when we take 5 and substitute it into this expression, the result is 0. When we take 5 and substitute it into this expression, the result is also 0. Now, that should make sense because when we found the solution to 8c right there, let's go back to our work. We found that, let's see here. Let's get some right here. These two things were equal. Now, I didn't use equal signs here. I should have. I should have said equals, and I should have said equals. That's my bad on the notation there. But what we did here is just multiply. This right here is just a factored version of this right here. This is called standard form. Whenever you have a polynomial in standard form, it's when everything you've taken care of, adding all your common terms, you've done any necessary multiplication, and you have arranged it such that the highest powers of x come first, followed by the lower powers of x. So x cubed, x squared. That's actually an x to the first power. We don't ever think about it being a first power, but that's actually a first power there. And if you really want to be kind of crazy, you can say there is x to the 0 power times 20, because x to the 0 power, as long as x is a non-zero number, is 1. So, but we can forget about that for the time being. But anyway, this is a polynomial in standard form, and again, these two polynomials are equal. In fact, the one in the middle is equal too. It's just we're not really worried about that intermediate step right now. So one way you can show, or you can demonstrate, that two polynomials are equal, at least over a certain interval, is to show that when you substitute in different values for x, you get the same result. Now, if this was an equation, we would call those results y values. For instance, if we had y equals and y equals, I have my pen turned off, so my mouse is not so pretty right now. If you had y equals, we would call those results y values. So that's how you can show polynomials are equal, at least over a fixed interval. Now, the way to show they're equal in general is a little bit different. You talk about the coefficients of the respective powers of x are equal. Is how you do that. But that's another discussion for another day. But what we did here is, in a very basic way, show that those two polynomials are equal. They are just simply different superficial versions of each other. They just look different, but they're actually the exact same thing. You probably knew that whenever we were solving back over here, because this line was equal to this line was equal to this line. So it made sense that this was equal to that. It's a transitive property kind of thing. But we showed it by substituting various values. Okay, so now, just like before, we want to type in conclusions here. So your conclusions, if I can type today, go here. So, kind of what we just discussed, how we were showing that these two polynomials are equal. They just look different. You need to type a few sentences about those conclusions here, and other than that, it's really done. Now, we could do things like make this look a little nicer. For instance, let's see here. If I select all this by member, again, if you want to select one corner of your data, hold the Shift key, select the other corner of the data, we can do stuff like center it all. That makes it look nicer. We could add borders. That might look make it look nicer. Let's see, all borders. What about outside borders? Let's see here. Let's what else can we do here? Anything else really? Nah, that's good enough. I think that looks good. So we have our input column, B and C, where we're evaluating that expression. And I think we've about talked about everything we can do. Now, of course, you need to make sure to name your file correctly, submit it on Blackboard. Make sure to pay attention to the due dates because you don't want to be late, of course. So save as. Let's see. Go to your somewhere where you're going to remember it, and then again the convention's last name underscore first name underscore the page number. This was page 303. Okay. All right. So that's all you have to do. Again, if you need any additional help, please feel free to stop by my office. Stop me after class, before class. I know a lot of people bring their laptops, and so we talk before and after class. That's fine too. Or you can always swing by my office. Take a stab at it. Watching the video, try to figure it out yourself, or maybe really try to figure it out before watching the video. Then watch the video if you need help, and then if you still need help, come see me. All right. I'll see you guys soon. Have a nice weekend, and I hope this has been helpful.